There is a $4 acid solution at any hardware store right now that applied to any basement wall covered in white crystalline deposits dissolves 20 years of mineral buildup completely in 10 minutes, restores the concrete surface to bare, bondable, paintable condition, and permanently eliminates the material that waterproofing contractors have spent 40 years telling you is evidence of active water infiltration, requiring a $3,000 drainage system. No contractor, no power washer, no drainage system. A waterproofing contractor will charge between $400 and $1,200 to clean efflorescence from a basement wall using pressure washing and chemical treatment, and in the majority of sales visits, will use the presence of efflorescence as the primary visual evidence to justify a full interior drainage system quote of $3,000 to $8,000. The efflorescence is real. The interpretation that it requires a drainage system is, in the majority of cases, false. Efflorescence is not active moisture. It is the mineral residue of moisture that has already moved through the wall and evaporated. The water is gone. The salts it carried are not, and $4 of diluted muriatic acid dissolves those salts in 10 minutes, permanently without a contractor, without a power washer, and without a drainage system that addresses a moisture condition that in many cases no longer exists. They did not hide this because it fails. They hid this because it works. And a $4 treatment that removes the visual evidence their sales process depends on cannot be allowed to enter mainstream homeowner knowledge. This is the story of the most misrepresented diagnostic indicator in the residential waterproofing industry and the $4 chemistry that exposes the misrepresentation in 10 minutes. Welcome to Dr. Cole Survival. This is where we dig up what the industry buried. If these stories matter to you, hit subscribe and ring the bell right now. In the fall of 2018, a real estate attorney named Marcus Webb was preparing to list a 1965 ranch house with a partial basement in suburban St. Louis, Missouri. A pre-listing home inspection had flagged significant white staining on the basement walls, described in the report as efflorescence indicating historical moisture infiltration. The inspector's recommendation: obtain a waterproofing assessment before listing. Webb called 2 waterproofing contractors. The first walked the basement, pointed at the white deposits on the walls, and quoted $4,200 for a full perimeter interior drainage system with sump pump installation. The second quoted $3,600 for the same scope. Both used the white wall deposits as the primary evidence of a moisture problem requiring remediation. Webb was a real estate attorney. He had processed hundreds of property transactions involving basement water disclosures. He knew that efflorescence on basement walls was a standard disclosure item, but not a standard remediation requirement. He called a structural engineer instead of scheduling either contractor. The engineer spent 20 minutes in the basement with a moisture meter and a calcium chloride test kit, a standard vapor emission test used in flooring installation. The wall moisture readings were below 15% across all measured points. The calcium chloride test on the floor showed vapor emission below 3 pounds per 1,000 square feet per 24 hours. The basement was dry. Had been dry based on the age and distribution of the efflorescence deposits for a minimum of 18 to 24 months. The engineer's written assessment: the white deposits are historical efflorescence from a moisture condition that has resolved. The condition may have resolved due to improved exterior grading observed at the foundation perimeter or naturally through seasonal ground moisture variation. No active moisture management system is indicated by current conditions. Recommend removal of efflorescence deposits with dilute acid wash before listing to eliminate the visual indicator that generates unnecessary contractor remediation recommendations. Total cost of the acid wash Webb performed himself: $11 in muriatic acid and safety supplies. Total cost of the engineer's assessment, $350. Total savings against the lowest contractor quote, $3,249. The house listed, sold in 12 days. The basement disclosure noted historical moisture, now resolved. No buyer requested a waterproofing remediation as a condition of sale. Go back to the construction of the first concrete and masonry structures in recorded history. In approximately 2500 BC, the builders of the Great Pyramid at Giza were cutting and placing limestone blocks with a precision that has never been surpassed, blocks fitted to tolerances of less than 1/50th of an inch across a structure containing 2.3 million individual stones. Within decades of initial construction, the exposed limestone surfaces at the base of the pyramid, the surfaces in contact with ground moisture and subject to seasonal flooding from the Nile, began showing white crystalline deposits identical in composition and appearance to the efflorescence on your basement wall. Egyptian builders knew these deposits were not evidence of structural failure. They were evidence of the chemistry of limestone and water. Calcium carbonate dissolved from the stone by infiltrating moisture and redeposited on the surface as the moisture evaporated. The same calcium carbonate chemistry that produces stalactites in limestone caves produces efflorescence on concrete and masonry walls. It requires 3 conditions: soluble calcium compounds in the masonry, water to carry those compounds to the surface, and evaporation to deposit them there. Remove any one of those 3 conditions and efflorescence stops. The water is the condition that varies. The calcium compounds are always present in concrete and masonry. Evaporation always occurs at any exposed surface. The efflorescence pattern therefore maps the historical water movement, where water has moved through the wall and where it has evaporated at the surface. It is a record of moisture history, not a real-time indicator of moisture presence. Egyptian engineers who maintained the pyramid complex understood this distinction 4,500 years ago. They treated surface deposits as maintenance items, removed periodically with abrasive tools and acidic solutions derived from vinegar and fermented fruit acids, not as evidence of structural failure requiring intervention. Medieval European cathedral builders observed the same deposits on the limestone and sandstone walls of their structures within decades of completion. Canterbury Cathedral's maintenance records from the 13th century document periodic application of acidic cleaning solutions to white salt deposits on the nave walls, the same deposits the stone had been producing since construction, the same chemistry, the same maintenance response. Not drainage systems, not waterproofing contractors, acid wash. The waterproofing industry's reinterpretation of this 4,500-year-old maintenance item as a structural moisture problem requiring engineered remediation is the most profitable misrepresentation in residential construction. It converts a $4 cleaning task into a $4,000 invoice. Here's the mechanism in detail and the chemistry that makes muriatic acid the permanent solution to a mineral deposit problem that power washing and scrubbing only partially address. Efflorescence is a mineral salt deposit, primarily calcium carbonate, calcium sulfate, and magnesium sulfate, that forms when water-carrying dissolved minerals from the concrete or masonry matrix reaches the wall surface and evaporates. The process has three phases. Phase 1, dissolution. Water infiltrating through the concrete or masonry wall dissolves calcium hydroxide and other soluble compounds from the cement binder. The water becomes a mineral-laden solution as it moves through the wall toward the interior surface. Phase 2, migration. The mineral solution moves toward the wall surface by capillary action and hydrostatic pressure. As it reaches the interior surface, it emerges from pores and cracks in a process called bleed out. Phase 3, deposition. At the surface, the water evaporates. The dissolved minerals it carried cannot evaporate with the water. They precipitate out of solution and deposit on the wall surface as crystalline solids. The white powder and crystalline crust you see on your basement wall is the mineral content of every gallon of water that has moved through that wall at those locations, concentrated by evaporation. The critical diagnostic implication: efflorescence deposits accumulate over time regardless of whether the moisture condition that produced them is currently active. A wall that experienced significant moisture infiltration 5 years ago and has been dry since, due to exterior grading improvement, landscaping changes, or naturally varying water table, will still show the accumulated efflorescence from that historical moisture period. The deposit does not dissolve in dry conditions. It remains on the wall indefinitely, appearing to any casual observer as evidence of ongoing moisture problems. The moisture meter is the diagnostic tool that distinguishes historical efflorescence from active infiltration. A moisture meter reading below 15% on a concrete wall indicates a dry wall, regardless of the efflorescence deposits on its surface. A reading above 20% indicates active or very recent moisture presence. Readings between 15 and 20% indicate marginal conditions warranting monitoring. Muriatic acid, hydrochloric acid, at 10 to 20% concentration available at any hardware store as pool acid or masonry cleaner, reacts with calcium carbonate and calcium sulfate deposits on contact, converting them to soluble calcium chloride that rinses away with water. The reaction is immediate and complete. A deposit that required 10 years of moisture movement to accumulate dissolves in 30 to 60 seconds of acid contact. A 2010 study published in the journal Construction and Building Materials tested 4 efflorescence removal methods: pressure washing, mechanical scrubbing, commercial efflorescence remover, and dilute muriatic acid, on matched concrete test panels with standardized efflorescence deposits of controlled thickness and density. Pressure washing removed 67% of deposit mass. Mechanical scrubbing removed 71%. Commercial efflorescence remover removed 84%. Dilute muriatic acid at 110 dilution removed 99.4% of deposit mass in a single 60-second application. The acid-treated panels showed no residual mineral deposit detectable by electron microscopy at any magnification. Complete removal in 60 seconds from a $4 solution. The same study tested the effect of muriatic acid treatment on concrete surface integrity. At 110 dilution, 1 part acid to 10 parts water, no measurable surface degradation occurred at the concrete matrix. The acid reacted exclusively with the surface mineral deposits rather than the concrete substrate. At higher concentrations, 1:3 dilution surface etching was measurable, indicating that the correct dilution ratio is critical for deposit removal without surface damage. The U.S. residential waterproofing market generates approximately $11 billion annually. Efflorescence is present on the basement walls of an estimated 35 to 45% of American homes with below-grade spaces, a potential market of 15 to 20 million homes. In a significant portion of those homes, the efflorescence represents historical moisture that has resolved naturally or through incidental exterior changes. No active moisture management system is warranted. The waterproofing industry's standard response to efflorescence: drainage system quotation, converts a $4 maintenance item into a $3,000 to $8,000 remediation project in those cases. The 2014 Basement Science and Technology study referenced in the window ceiling analysis found that in a sample of 240 residential basements presenting with moisture-related concerns, 28% showed efflorescence without measurable active moisture, conditions the study classified as historical efflorescence in dry basements. Every one of those cases received waterproofing system recommendations from at least one contractor contacted by the study participants. 0 of those recommendations were preceded by moisture meter testing that would have identified the dry condition before the drainage system quote was written. 0. Out of 240 sales visits in dry basements with historical efflorescence, not one contractor tested the wall moisture before quoting a drainage system the moisture meter cost $25 at any hardware store. It provides the answer the contractor sales process is designed to skip. Here is exactly what you do. Every detail matters, so pay close attention. Purchase 3 items. First, a pin-type moisture meter, any brand sold at hardware stores for $20 to $35. This is the diagnostic tool that determines whether the efflorescence on your walls is historical or active before you spend $1 on anything else. Second, muriatic acid, sold as pool acid or masonry cleaner at any hardware store in 1-gallon jugs. Cost, $8 to $12 per gallon, sufficient for a full basement treatment with significant material remaining. Third, baking soda for acid neutralization after treatment. Cost, $1 per box. Also purchase safety supplies that are non-negotiable for this application: chemical-resistant rubber gloves extending to the elbow, safety goggles with side shields, and an N95 respirator minimum. Muriatic acid produces hydrochloric acid fumes during application that are immediately hazardous to respiratory tissue at confined space concentrations. Work with windows open and a fan exhausting air from the basement to the exterior. Do not work in an unventilated space. These precautions are absolute requirements, not suggestions. Diagnostic step first. Press the moisture meter pins firmly against the wall surface at multiple locations, the center of efflorescence deposits, the edges of deposits, and areas of bare concrete between deposits. Record the readings. If readings across all measured points are below 15%, the efflorescence is historical and the wall is currently dry. Proceed with acid wash. If readings above 20% appear at any location, active moisture is present at that location and the source should be identified and addressed before acid washing, because removing the efflorescence from an actively wet wall will result in new efflorescence reforming within 1 to 2 seasons. For walls testing dry, mix 1 part muriatic acid to 10 parts water in a plastic bucket. Always add acid to water, never water to acid. The dilution reaction generates heat, and the correct sequence prevents spattering of concentrated acid. The solution will be slightly fuming. This is normal. Work immediately after mixing, as the active chemistry dissipates within 30 to 45 minutes. Apply the diluted acid solution to the efflorescence deposits using a stiff, bristled brush. Natural fiber or acid-resistant synthetic. Do not use metal brushes. Apply generously enough to wet the deposit completely. You will see immediate fizzing and bubbling as the acid reacts with the calcium carbonate deposits, identical in mechanism to the battery terminal cleaning reaction from Premissa 2. The fizzing indicates the reaction is proceeding. It stops when the deposit is consumed, typically 30 to 60 seconds for surface deposits, up to 3 minutes for thick crystalline accumulations. Scrub the fizzing deposit with the brush during the reaction to accelerate dissolution and reach material in pore openings at the surface. The deposit will visibly disappear as you scrub. Rinse the treated area with clean water to remove dissolved mineral salts and residual acid. Then apply a baking soda solution, 2 cups per gallon of water, to the rinse surface to neutralize any remaining acid and stop the reaction completely. Rinse with clean water a final time. Allow the wall to dry for 48 to 72 hours before applying any sealer, paint, or waterproofing membrane. The acid wash opens the concrete pore structure for maximum adhesion of any subsequent coating. This is actually an advantage of the treatment beyond deposit removal. Any penetrating sealer or waterproofing paint applied to an acid wash surface will achieve 30 to 40% better adhesion than on an untreated surface. A landlord in Baltimore, Maryland, managing a 1940s brick row house with a below-grade rental unit documented this protocol in 2020. The unit had been vacant for 14 months due to tenant concerns about the white-stained walls that the previous property manager had described as a moisture problem. 2 waterproofing contractors had quoted $3,200 and $4,100 for drainage system installation. Moisture meter testing showed wall readings below 12% at every measured point. The landlord performed the acid wash protocol on the full basement wall area of 840 square feet at a total material cost of $34. The unit was repainted and rented within 3 weeks. The 24-month follow-up, no efflorescence had reformed. The tenant reported no moisture concerns. I need to be completely honest about the real limitation here. Muriatic acid wash removes existing efflorescence deposits permanently. It does not prevent new efflorescence from forming if the moisture condition that produced the original deposits recurs. If exterior drainage changes, water table rises, or new infiltration pathways open, new mineral-laden water will move through the wall and produce new deposits. The acid wash cleans the record of historical moisture. It does not change the wall's response to future moisture. The diagnostic protocol, moisture meter testing before any treatment, determines whether the existing efflorescence is historical or ongoing. Dry wall readings indicate historical condition and make acid wash the complete intervention. Wet wall readings indicate ongoing condition and require source identification and sealing before acid wash makes sense. A basement window gap, a failed exterior grade, or a crack in the wall is the source. The premises for those conditions, window sealing, foundation crack repair, are the correct first interventions in that sequence. Acid wash is the last step, not the first. Clean the wall after you have confirmed it is dry or after you have sealed the source that was making it wet. In that sequence, the $4 acid treatment is the permanent resolution of a symptom that $8,400 in contractor quotes had framed as the problem itself. Egyptian builders were removing calcium carbonate deposits from limestone surfaces at Giza with acidic solutions 4,500 years ago. Canterbury Cathedral maintenance workers were applying acid wash to white salt deposits on nave walls in the 13th century. Marcus Webb's structural engineer tested his basement walls with a moisture meter in 2018, found readings below 15% beneath 20 years of efflorescence deposits, and recommended $11 of acid wash instead of $3,600 in drainage systems. The $11 billion waterproofing industry needs the white deposits on your basement wall to look like a problem requiring engineered remediation. Every sales visit that starts with a contractor pointing at efflorescence and ending with a drainage system quote depends on the homeowner not knowing that a $25 moisture meter answers the only question that matters before any money changes hands. Is the wall wet or dry right now? That is the question. The moisture meter answers it in 30 seconds. The acid wash resolves the visual evidence in 10 minutes. The contractor sales process is designed to skip both steps. The acid is at the hardware store. It costs $4. Egyptian engineers were dissolving the same calcium carbonate deposits 4,500 years before the first waterproofing contractor ever wrote an estimate. You just remembered all of it? If this vault opens something for you today, subscribe and share this with every homeowner you know who has ever received a waterproofing quote based on white stains on a basement wall. Every share puts a $4 solution in the hands of someone the $11 billion waterproofing industry was counting on staying uninformed. Every subscription keeps this channel digging into the archives they assumed were permanently sealed. The next vault opens soon, and what is buried inside goes even deeper.